You can spend an hour reading an AI paper, understand the architecture, understand some equations, even understand the results. And then somebody asks, so what did this paper actually do? And suddenly your brain says, well, there was this module, let me think. And then they changed the laws, and then there was also attention, and so on and so on. So 20 pages of reading, zero clean sentences. I have been there too. And actually, this is one of the biggest differences between reading a paper and understanding the paper. Because understanding every detail is useful, but not every detail in the reason the paper exists. Today, I want to find that particular reason. I In the last few episodes, we have been slowly getting inside research. First, we opened the door, then we made a map. Last week, we made technical language and equations a little less hostile, so now you can actually move around the paper. But once you can move around, something interesting happens. Everything starts looking important. The architecture sounds important, the loss function sounds important, the training setup sounds important, the dataset sounds important too. The authors have also very kindly named everything with capital letters, so now everything looks extremely important. But somewhere inside all of that is one change that gives the paper its identity. That is what we are looking for. I'm Hamza. I work in AI research and build real AI systems. And this is Paper Fearless. One paper, one clear idea, one buildable move. Although today we are stopping just before the buildable move, because first we need to know which idea is actually worth carrying forward. Let me use a very normal situation. Imagine somebody sends you a photo on WhatsApp and they ask what number is written on the motorcycle in the back. So what do? You probably do not carefully inspect every tree, every building, every person, every pixels in the entire photo. You understand the scene quickly. Then you think motorcycle back, probably there, and then you zoom in. That feels completely normal to us, right? We use a rough view first, then more detail where we actually need it. Now, here is where recent AI paper becomes interesting. At CVPR 2026, researchers introduced a system called AdaptVision. It works with vision language models, the kind of AI that can reason about image and answer questions about them. And there is a practical problem with these models. So images can become expensive. A detailed image gets broken into lots of visual information for the models to process. More detail can mean more visual tokens. More tokens mean more computation. One common solution is basically fine, compress the image, but that saves computation. There is an obvious problem also. Sometimes the detail you remove was exactly the detail the question needed. So think again about that motorcycle compressed too aggressively, and goodbye number plates. So the AdaptVision researchers asked a much more interesting question. Why would the model decide beforehand how much detail it needs? Why not let it start with a rough view and then request more detail only when necessary? So that's the idea. The model first receives a compressed lower resolution view. If that is enough, great. So answer the question. But if an important region needs closer inspection, the model can select that region, crop it, and acquire more visual information. Basically, I think the answer is over there, so let me look it closer. So now the paper contains reinforcement learning. It contains a training method called DTPO. It has objectives for learning when to use the tool. It has objectives for improving answer accuracy. There are experiments, benchmarks, comparisons, plenty of technical material to keep your coffee employed. But here is our question: which of those things is the paper? So this is where I use very simple story: before, change, and after. So before this paper, we have to understand like what was before this paper. Efficient vision language models often reduce visual information using a fixed compression strategy. The problem is that different questions need different amount of visual detail. Then comes the changes. So instead of deciding the amount of visual information once and treating every case the same, AdaptVision lets the model actively acquire more detail when the task needs it. And after, the researchers show that the model can perform strongly across visual questions, answering benchmarks while using substantially fewer visual tokens than other efficient approaches they compared against. So that is the paper. Everything else helps explain it, train it, or prove it, and this distinction matters because when you are new to papers, one very natural habit is to collect information. You think, if I understand more pieces, eventually the main idea will reveal itself. Sometimes it's true, yes, of course, but sometimes you end up with 15 pieces and no idea which one belongs in the center. So there is question that I use like I really like this one, so you can ask, if I remove this thing, does the paper still exist? Imagine AdaptVision without one small training details. Maybe performance changes, maybe training becomes harder, but the basic research idea could still be recognizable. So now remove the ability to start course and actively acquire more visual detail when needed. What is left? You have basically removed the reason this particular paper exists. That is a strong signal. The important idea is often the thing you cannot remove without turning the paper back into something much closer to what already existed. This is also why the move from our week 2 method and the core idea today are related, but they are not exactly the same question. In week 2, we asked what did the researchers introduce, but that give you the orientation. Today, we are asking of everything they introduced, which change actually connects the old problem to the new possibility. So that gives you the center. Let me give you a completely different example. Think about smartphones. Every year a new phone might arrive with a brighter display, a slightly different camera, a faster chip, new software features, better battery management, and 17 things with the word AI attached to them. But imagine one generation suddenly gives you a battery that genuinely lasts 3 days without making the phone thicker. That is probably the story people remember. The new wallpaper is still a feature. The camera button may still be useful, but they are not carrying the identity of that generation. So research papers are similar. A paper can have many improvements. The contribution is the change that makes you say, that is why this needed to be a new paper. And finding that change matters for more than exams and literature reviews. It matters when research becomes a real system because it is surprisingly easy to reproduce the shape of a research paper without reproducing its reasoning. You can copy the architecture, use the same backbone, add the same laws, follow the GitHub repository, and still completely misunderstand why those choices were made. That becomes dangerous when people take research into real applications. because the original researchers may have designed something for one very specific limitation. You copy the solution, but your problem does not actually have that limitation. Now you have technically reproduced the method and practically solved the wrong problem. This is one of the reason I care so much about the question behind the architecture. As a researcher, yes, I want to know how the system works, but as a builder, I also need to know why that system needed to exist in the first place, because the why tells me which parts are essential and which parts are simply how this particular researchers made the idea work. So AI tools can help here too, but again, I would not simply ask ChatGPT or Gemini what is the contribution of this paper. You might get 5 bullet points copied from the abstract. Technically correct, not always very useful. So try something harder, maybe by asking what could system not do well before this work. Then what single change in this paper responds most directly to the problem. Then if I remove that change, would the paper still be meaningfully different from the previous approach? And finally, explain the papers as before, change after. So now you are making the AI reason about the relationship between the problem and the contribution. But still, go back to the paper, check the introduction, check what previous approaches it struggled with, check the method, and especially check the experiments, because researchers can say an idea matters. The experiments should show what changed because of it. So after this video, take one paper, maybe one you already used in the previous episodes, and do not summarize it. Just give me 3 sentences before this paper. What was missing? The researchers changed. So what did they actually do differently? This made it possible to, like, what become possible, better, cheaper, faster, or safer, or more useful because of those changes. So 3 sentences, if you can say those 3 clearly, you probably have the center of the paper. And if you cannot yet, that is actually useful information. It tells you exactly what you still need to understand. And that completes our first month of Paper Fearless. 4 weeks ago, the problem was simply opening the door. Then we learned where to begin. Then we crossed the technical language, and now you can start separating the idea from all the machinery around it. That is a very different way of reading a research paper, because now a paper is no longer just 20 pages you need to finish. There is a question inside it. There was a world before it. Someone changed something, and because of that change, a new possibility appeared. But now we reach the interesting part. Once you can find the idea, what do you do with it? Because a student can understand an idea, a researcher can question it, and a builder starts wondering what else could this become. That is where month 2 begins, and that is our next Paper Fearless. Thank you.